Good day, viewers. Welcome to today's tutorial. All right. So in today's tutorial, I want to treat these variable concepts. We have been differentiating algebraic expression. We have been differentiating all these simple functions. All right. But today, I want to introduce what we call transcendental functions. I want to introduce it to us. All right. Don't forget, this is Mathematics Clinic by Tutor Chris. And in these videos, I will just be telling us the root of these transcendental functions, how it arises, and what I mean by transcendental functions. Okay, so I promise not to solve any problem here. Okay, so don't be scared. All right, now what do we call transcendental functions? They are functions that cannot be expressed as finite combinations of algebraic operation. They cannot be expressed. They are functions. They are functions. They are functions that be expressed. Cannot be expressed as they cannot be expressed as finite combinations. Finite combinations, okay, of algebraic operations. Of algebraic. Oh, sorry for that. Oh, let me clean this. Okay. Of algebraic operations. Algebraic operation. All right. Algebraic operations, like when we are talking about the algebraic operation, the addition, subtraction, multiplication, and division, or taking the roots. Okay, subtraction, division, multiplication, okay, and taking roots. All right, this is what we mean by transcendental functions, and I would like you guys to just jot this down in your jotter so that you will be able to remember this. Okay, so in simpler terms, they go beyond algebra. That's what we are trying to say. They go beyond the algebra. They are not polynomial equations with finite step. All right, I hope you are getting that. Now, I would quickly like to tell us a little stories about these transcendental functions. Okay, let's move to the next page now. All right. So the idea of transcendental functions developed gradually over centuries. Okay, but the terms and systematic study are mostly strongly connected with the great Swiss mathematician, which is known as Leonhard Euler. In the 18th century. In the 18th century. Okay. All right. So, before Euler, mathematicians already used the functions. Many mathematicians have already used the functions like logarithms. They have used functions like logarithms. Okay, they have used exponentials okay, and trigonometric functions. trigonometric functions. Okay, they have made use of this even before this man, which we called Leonhard Euler in the 18th century. They have made use of all this before him. Okay, for example, of those that introduced, for example, the person that introduced logarithm is called John Napier. You should have heard about John Napier in your computer science. Okay, John Napier this man introduced logarithm. Okay, he introduced logarithm in the early 1616. Okay, all right, let's also move to the next page. All right, guys, also we have someone we call René Descartes. He also worked on algebraic curves. René Descartes, I don't really know about this man. Okay, you can research better about him. Okay, René Descartes, he worked on algebraic oh, sorry for that. Worked on algebraic curves. All right, you might be wondering, why is this man telling us stories like this? Okay, the reason I'm making use of all these stories is that I want you to know the root of what you want to look at, okay, so that you have a deeper understanding of this concept. Okay, don't be in a hurry. Okay, we are going to solve problems, don't worry. Now, also we have someone we call Sir Isaac Newton. You should have heard about the man before. Sir Isaac Newton, okay. And also the person we call Leibniz. Isaac Newton and Leibniz, they really invested a lot in what we call calculus. They worked a lot in calculus. So Isaac Newton, Sir Isaac Newton is a great man. He worked in diverse fields. Newton, and we have Wilhelm Leibniz. They are the one that developed calculus. Okay, which used many functions. All right. Okay, but these functions are not yet formally grouped as transcendental then. Okay, now here comes this man which I've been talking about, that is Euler, which was the first mathematician to distinguish between algebraic functions. Distinguish algebraic functions from algebraic functions. We distinguish it from transcendental functions. Transcendental function. Okay, this is the man that differentiates between both of them. He used the term transcendental for functions. Okay, let's move to the next page. So he used the term transcendental for functions that transcend algebraic operations. Okay, he also developed many famous transcendental relationships, which include the popular formula, which we know as the Euler's formula, that is exponential over ix, which is equals to cos x plus sine I sine x. Okay, is the one that developed this, which everyone now know as Euler's formula. Okay, all right, you can see this is a very beautiful concept. Now you can see this formula connects to exponential functions. It also connects the trigonometric function. It also connects the complex numbers. This man really tried. I love the man. Complex numbers. Okay. All right now. I will briefly tell us why the name Transcendental. You should be wondering why the name Transcendental. Why the name Transcendental. By the end of this tutorial, you will be able to know the origin of this. Okay, it means to claim beyond, to claim beyond, to climb beyond. Okay, sorry, it means to climb beyond or go beyond, or go beyond. That's the meaning. All right. So transcendental functions are functions that go beyond ordinary algebra. They are functions that go beyond ordinary algebra. Okay? Later on, mathematicians discovered that some numbers are also transcendental. For example, the pi constant, the exponent function, that is e. These are not root of any polynomial equations and integer coefficient. Okay, all right. I will have to move to the next page now. Yeah. The transcendence of E was proved by the transcendence. Let me write that down for you so that I can jot it down. The transcendence of E was proved by this man which we call Charles Hermite in 1873. Okay, why the transcendence of why the transcendence of pi constant, okay, was proved by this man called Ferdinand von Lindemann. All right, okay, Lindemann in 1882. All right, this is good. Now, I would also like to share with us some importance of these transcendental functions we have been talking about since morning. Okay, I would like to tell us why it matters. Let's go to the next page. Okay, why these transcendental functions matters, why they matters. Why they matters, why you have to understand them. Okay, they appear everywhere in science and engineering. For example, in physics. For example, in waves, motion, and electricity, they appear there. The basis of all these concepts. Okay. Now, also in biology, it appears in population growth. In economics, you can see this concept really matters. They appear in compound interest, which you have been doing since your basic education level, compound and simple interest. I hope you can still remember that. Let me know in the comment section if you can still solve problem there. Maybe I should just give you a little problem so that I will check your understanding about simple and complex interest. Oh my god. Right. Okay. In engineering, they appear in signal processing. Signal processing. All right. Appear in signal processing. Okay. And when we are talking about all these transcendental functions, I said they include exponential functions, they include logarithmic functions, they also include trigonometric functions. Okay, now these are what they include. The first one is exponential function. Exponential functions. And example of exponential function are e of x, a of x, and so on and so forth. Okay, which is used in growth processes. Okay, population, finances, etc. Okay, now we also have a logarithmic functions. Logarithmic functions. When we are talking about, for example, ln of x, that is the inverse of exponential functions. The inverse of exponential functions. Okay. Now we also have that's trigonometric function. Trigonometric. Oh, trigonometric functions. Okay. We're having sine of x, cos of x, tan of x, okay, and so on and so forth. All right, so I think I've been able to give us a detailed history, a little story about transcendental functions. So in my next video, we'll be diving into problems. We'll be solving problems together. We'll be looking at some tricky problems. We start from easy one to the hard one. Okay, so don't be scared. Step by step, a block at once. Okay, we are going to build this building and we start from foundation. All right, so if you like this kind of video, subscribe to my channel, turn on your notification so that when next I upload the next videos on this concept, you'll be able to be notified and you'll be able to watch the video. I hope you get what I'm trying to say. Thank you. See you next time.